graphing a linear equation. This is from Chapter 4, Section 4.1. We're going to graph a linear equation using a table of values. So first we need to know what a linear equation is. A linear equation is an equation whose graph is a line. It looks like this. Y equals x plus 1 is an example of a linear equation. The points on the line that lie on the line on the graph are called solutions of the equation. So we are going to graph y equals x plus 1 by making a table of values first. And then we will plot our ordered pairs. Then we will draw a line through those points to draw the line of the graph. And then we'll describe it. Okay, so here is our table of values. Notice that our x values are given to us. These are the values we're going to plug into the equation. So the equation is also written here for you, y equals x plus 1. Notice there is an example. So your x value is -2. So when you plug that into the equation, it's y equals -2. Instead of the x, you've plugged in the value -2 plus 1. And -2 plus 1, you could use a calculator or your mental math skills. -2 plus 1 is -1. So when you write it as an ordered pair, you have your x, y value, -2, -1. This is your ordered pair. It is a point that lies on the line. It is also called a solution of the equation. So let's go ahead and do the next one, -1. So I'm going to write out the equation y equals, I'm going to put parentheses where my input value for x will go, and then write +1. In fact, I'm going to go ahead and do that on all of them. Y equals, I'll create a space for my x plug-in value. Okay. Now, it tells us what value to plug in for x. It wants us to plug in -1. So I'm going to put -1 here. Now we're going to plug in 0 on the next one. And plug in 1 and 2. And now I'm going to do the math calculations. So -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. I see a pattern, 0, 1, 2, 3. And now we are going to write these as ordered pairs. I'm still going to color code so that you know which is which. So I'm just going to draw my parentheses with my commas so I can show you where my x and y's go. So notice it goes x, y always, okay? So whatever you plug in should be your first coordinate. It's your x coordinate. And the solution that you got when you solved for y will be the second coordinate. So we have -1, 0. So I'm going to write that as -1, 0. That is the first solution we got. Now we have 0. When we input 0, we got 1. So we're going to write 0, 1. And 1, 2. And 2, 3. So these ordered pairs that we got are solutions of this equation, this linear equation. All right, step 2, we need to plot those ordered pairs. So I'm going to shrink this a bit. Okay, so let's plot our ordered pairs. First, we have -1, 0. Remember, I always want to start at the origin of my graph. It's where the x and y axis intersect. -1 means to move left 1 unit, and because it's -1, 0, I stay put. I do not move up or down. So there's my first point. My next point is 0, 1. So I start at 0, 0, and I don't move left or right because it's 0 for my x, but I move up 1. 1, 2 means move right from the origin 1 and up 1, 2 units. And 2, 3 means start at the origin, move right 2 units and up 1, 2, 3. Notice that these solutions, these ordered pairs, lie on a perfectly straight line, hence our name of linear equation. Now you definitely want to use a straight edge to connect your points so that your line from your ruler goes through the middle of each point. And you want to draw your lines, stretches from the edge of the plane all the way to the other edge. You don't just want to put your line through these points. You want to extend it and put arrows at the top and the bottom, and that represents that the line keeps going forever. So you just graphed the line of a linear equation using solutions from a table of values. So to describe this graph, we would say a linear equation that is a straight line. And what this means when it has a straight line like this, it has a constant rate of change. A constant rate of change means this straight line, as you notice the pattern in our ordered pairs. It's moving up, 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 up at the exact same rate. That is our slope that we will talk about in 4.2.